and Assalamualaikum. In this video, we gonna present group project of statistics for real estate management. Here was my group members: Hasnita Natasha binti Hadi, Lee Ziying, Michelle Ino Anak Saleh, and Nur Fadila Atasha binti Abdul Hamid. Simple linear regression is a statistical method that allows us to summarize and study relationship between two quantitative variables. Firstly, one variable denoted x is regarded as the predictor or independent variable. Next, the other variable denoted y is regarded as the response outcome or independent variable. This is because the other terms are used less frequently today. We'll use the predator and response terms to refer the variable encountered in this course.
Hi, I'm Li Jing. I will introduce scatter plots. A scatter plot is a graph of the order pairs S and Y of number consisting at the variable S and the dependent variable Y. This is data the relationship between student hours and their grades achieved. S represent the student study hour, independent variable. Y represent grades achieved, dependent variable. This is the table below.
Assalamualaikum warahmatullahi wabarakatuh. I am Nur Fadila Atasha. Now we want to get a square line. The formula is y to equal beta non plus beta I s. So first we need to find s y. The formula s and y is summation xy minus 1 over n times summation x times summation y. From the table we have xy is 178.5, 858, y 95 and 13. So we calculate xy, we get 1658.17. Next, we need to find SSX. The formula of the SSX is summation x power of 2 minus 1 over n summation time x then power of 2. From the table we have f power of 2 is 126. So we calculate the SSX, we get 122.222. So next we calculate to beta I. Formula of the beta I SXY over of SXX. We get 13.562. Formula of beta non is the mean of y minus beta I times the mean of x. From the table, the mean of y is 3.17 and the minus of x 1.93. So we calculate beta non, we get negative 23.005. So last, y equal beta non plus beta I x, we get negative 23.005 plus 30.562x.
Welcome to this part, Doctor. My name is Michelle Ino Anak Saleh. For this part, I will be discussing about coefficient of determination and Pearson correlation from our case study. The coefficient of determination measure the variation of dependent variable that is explained by the regression line and the independent variable x. The symbol for the coefficient of determination is r squared. To find the value of coefficient of determination, we need to find the value of SYY. The value of SYY can be found with putting the value of summation y squared minus 2 summation of y and multiply to the power of square. And after calculating our SYY, value is 4.1667. After our coefficient of determination equation is completed, we can get the answer of 5397.26. Next up is coefficient of Pearson correlation. Correlation exists between two variables when one of them is related to the other in some way. The coefficient of Pearson correlation measures the strength and direction of a linear relation between the two variables. The symbol for the sample Pearson correlation coefficient is R. The symbol for the population correlation coefficient is P. When R is between 0 to 0.5, the correlation between variables is positively weak or negatively weak. But when R is equal to between 0.5 to 1, the correlation between the variables is positively strong or negatively strong. There is no correlation between the variable if it's equal to 0. The equation for Pearson correlation is R equal to the value of Sxy divided to square root of the value from Sxx times by Syy value. After putting all the equation information, we can get the answer of 73.4661, which is 73.4661 is a strong correlation because it's greater than 0.5. That is all for my part. I will pass the next part to my friend. Thank you.
In conclusion, regression analysis is used in the broader sense. However, it is based on quantifying the change in the dependent variable due to the change in the independent variable by using the data on the dependent variable. Study of how a response variable depends on one or more predictor. Usually, dependence is assumed to be through the mean, and we think of the mean or regression function as describing how the mean of the response depends on the predictor. That's all from my group. Thank you.